Okay, so the conversion, we could read this, would be if P then Q,
section 3.6 now,
resigns, then the VP becomes president.
Syllogistic arguments using
Also, we have
using Euler
the
diagrams.
president becomes the vice president becomes
you can
president.
identify
So
these
statement Q
arguments
down here,
usually
premise
because
2.
of the words that are used.
And then therefore, it's a conclusion. President of the art club resigns.
Phrases like all are,
So
some
therefore
are,
P.
none are, some are
So
not,
over here,
etc. That's
we
the giveaway
can
that you're working with what's called a
fill up
syllogistic argument. And we're going to
our
use
table.
Euler diagrams to
Here's our usuals.
identify if the argument is valid or invalid.
And here
So
we want
let's get started.
this
First
P,
one.
then Q.
I'll illustrate the method as I do an
And
example here.
Q. All of that. P. So this is what we're seeing.
Okay,
Okay, so constructing
the
this
first
one,
example,
false here. And the rest are true.
we have that
Q, just copy it over. TF, TF.
well, it says,
And here we must have a true.
hold on.
Here's a true. These are falses. And is only true if there are two trues connecting. Okay, then this one now will be used over here. P. If the president resigns,
so here we are,
VP becomes
and I
president.
tried to get this neater for this problem.
Assume that's true. Then, and if
you
Q
can see it's
happens, in other words, Q is true.
roughly looks like this on
VP
the,
became president.
Example handout. You'll
Does
see
that
something
imply
looks like
that
this.
the VP or the president himself resigned?
Well, it should have
You
just
know there are
read
more ways for the
all
VP to
ballerinas
become president. What if
are athletic. And that Michael Jordan is an athlete. Or in other words, he is athletic.
the president, he didn't resign, but he was
Therefore,
maybe
MJ
impeached. And he didn't resign, he was impeached.
ballerina.
In that case, maybe the VP would become president.
Okay, so
So
the idea is
you can't
this: you're going to
assume that just
construct.
because
It's kind of like a Venn diagram
Because
in a sense.
the
Euler
president
diagram.
resigned.
You start with a set, draw a circle, and since this says all ballerinas are athletic, we're talking about two types of people: ballerinas and athletic people. It says all ballerinas are athletic, so we would have the athletic
That's why it's
circle.
considered a fallacy.
And with it, I mean, it would look like this. You have that entire set of ballerinas inside the athletic circle. Because it says all ballerinas are athletic. It's impossible for somebody to be a ballerina and not be athletic. That's what that says. That's what the diagram tells us. Anybody who's a ballerina must be in the athletic circle. Now, and here comes MJ. He belongs in the athletic circle. Now, the idea is that you're trying to pick a hole in this argument, the burden is on you to show that this conclusion that's drawn over here, this conclusion, you're trying to prove that it does not follow, that it's not necessarily, it doesn't have to be this way. So that's where you come in over here, and you got to place MJ somewhere in here.
Okay,
all we know is he's athletic.
So the alternating series test.
In our argument, we would put MJ here.
Okay.
So that he's not in the ballerina circle, and yet he's still athletic.
Now it's a little rough here, but these are examples from the handout, and this is an alternating series you can see. And first thing would be to check if that limit.
So what we've shown is that the argument in this
Z
form,
equals 0.
syllogistic argument is invalid
And
because
the answer is yes.
we can maintain the truth of our
Second,
premises
is it not increasing? So
and
yes,
show
n
that
plus
this
1 is
conclusion
n less
doesn't
than or
have to
equal to a
follow.
sub n. That's your question.
We've drawn
Okay.
our diagram
Well,
so that
let's show
Michael
that it
Jordan
is
is not
1 over
in the
root
ballerina circle.
n plus 1.
So that's, if you
We'll assume
can't
it's less
possibly
than or
do
equal
that
to 1 over
with one of these diagrams, then you have to assume that the argument
and
is
let's show
valid
that for what n that's
Maybe
true.
you're
We can
wrong.
cross multiply.
because you didn't look at all possibilities
So
for
we have
construction.
this.
But the
We
idea is you
square
have to
both sides.
prove that the
We're
argument
going to have this.
either must follow, this
These are all
conclusion
positive
must
numbers,
follow,
so this
or
is
that it can't
fine.
possibly follow. There's a way that it won't follow.
no problems.
So
And this
that's
is,
up to you.
leads to this,
All right, let's do another
which
one.
is true independent of n. So
Number 2.
this will be true for all n.
Okay. This time we have, and I'm taking this right off of the
Okay.
handout. We have that
Now-
soap floats in water.
Got those
So-
two shown to be
Because they also
checked? Yes.
soap also.
So it is convergent
So
by AST. Notice that the same
it
series
says things that float
without
float are
the
lighter than
alternating
water. So
characteristics there would not
here's let's write this as
converge
things that float.
because it would be a p series with p equal to a half. So the alternating makes a difference. Okay, this next one down here.
Those things that
um,
float
Here, I think we can see the first condition
are lighter than
is
water.
pretty clear. And even though we don't work a lot with the factorials, that will head to infinity. So there's the fraction heads to 0.
Because
Check.
it
Okay,
says
second,
things that float are lighter than
um,
water. So
again,
when it
is
says
the a
things,
sub
we
1
assume
plus
all things.
n plus
because it
1
didn't
less
say
than equal
some
to a
things.
sub n. And
Just
I
like
have to
it
show
said
that
soap
that's
floats,
true.
we
We
assume
believe it
also,
is, but
because it didn't
we
say
got to do a little
some.
bit of work here. So, 1
So
over
now,
n
where does
plus
soap
1
go in here?
factorial is that less than or equal
Well,
to 1 over n factorial.
when I say
Well,
things that float, I mean things that
Let's
float
see,
in
again,
water.
multiplying would give n factorial
So,
less than or equal to n plus 1.
okay, so where does
factorial.
soap go? Well, it's one,
And
it's in here. It has to be in here because it has
I
to
think
be.
it's pretty clear at this
something
point
that
that this is
floats.
true.
So it's
don't
definitely
really
in
have-
here, which automatically puts it
Let's
into
see,
the
we can
lighter
do a
than
little
water
bit more. Let's divide by
circle. Since it's inside this circle, anything inside this things that float circle
n
is inside this
factorial
other
here,
circle.
like this. See where this
So
takes
that
us.
means soap
This is
must be
1,
lighter than water.
and this is n plus
So
1
we would have to say that this one
times
is
n
valid.
factorial over n factorial.
We couldn't draw the diagram accurately
And
to
cancel.
show a
And then we
conclusion.
look at this. 1 is less than or equal to n plus 1. So this is 0. So this will be true as long as n is greater than or equal to 0, which it is.